Another counting rule that we see is the sum rule. And this is used when there are lots of different ways to do one single task. So if you can do one task P ways or Q ways, then the total number of ways is P plus Q. And so when you think about that key word in there, you want to look for that word or. And so the important part to remember is that these are independent ways, meaning they don't really have any overlap, right? If you're going to pick two friends and one of your friends came from one group and another friend comes from a different group, but those two groups don't have any overlap. And so then you would say the total number of ways I have is this plus this. And so you want to remember that there can't be any overlap, no overlap in the ways in the two groups. So an example of this is the mathematics department must choose either a student or a faculty member as a representative for a university committee. So notice that they're only choosing one representative, one single representative. So they're doing one task. How many choices are there for this representative if there are 37 members of the math faculty and 83 math majors? And no one is both a faculty member and a student. So that tells you that there's no overlap. Here's that word or sticking out at you. So the number of ways is going to be the number of ways to pick a student plus the number of ways to pick a faculty. So 37 plus 83, 120 ways. So they have 120 different choices in who they appoint. Now this is a really sort of simplified example of how we use the sum rule. I want to do one where you have to think a little bit more about what the number of ways for each choice is. So this one says each user on a computer system has a password, which is 6 to 8 characters long, where each character is an uppercase letter or a digit. Each password must contain at least one digit. How many possible passwords are there? So when we're thinking about this, we're saying the word or. We're saying the password can have 6 characters or 7 characters or 8 characters. So what we're going to do to find the total number of passwords is we're going to do the number of 6 character passwords plus the number of 7 character passwords plus the number of 8 character passwords. Okay, so to find the number of 6 character passwords, we want to think about what does a password have to look like. It says each character is an uppercase letter or a digit. So an uppercase letter or a digit. That means there's 36 choices for each character because 26 letters and 10 digits. Each password must contain at least one digit. So the way I'm going to do it is I'm going to say, I'm in the 6 character password. So 1, 2, 3, 4, 5, 6. I have 36 choices for each of these spots. But I want to exclude the ones that have no numbers, no digits. So the ones that don't have any digits look like all letters. So there would be 26 choices. So this is 36 to the 6th, excluding minus 26 to the 6th. So we can do that for each piece. So the 7 character passwords are going to be 36 to the 7th minus 26 to the 7th. The 8 character passwords are going to be 36 to the 8th minus 26 to the 8th. So in total, I have 36 to the 6th minus 26 to the 6th. That's the number of 6 character passwords. Plus 36 to the 7th minus 26 to the 7th. That's the number of 7 character passwords. plus 36 to the 8th minus 26 to the 8th. That's the number of 8-character passwords. So whatever that number is, that would be your total number of possible passwords that meet that criteria. So notice I had to use the sum rule because I said the word or, 6 or 7 or 8. And I used the multiplication rule here, the product rule, to get the number of passwords for each spot.